In this lecture, we are going to generate a perfect numbers less than or equal to n. We know that a given number a is said to be perfect number if the sum of all divisor of a is equal to a. That is, for example, 6 is a perfect number. The all divisors of 6 which are less than 6 are 1, 2, 3, and their addition is 1 plus 2 plus 3 is equal to 6, which is number itself. Okay, so 6 is a perfect number. Again, 8 is not a perfect number. All divisors of 8 which are less than 8 are 1, 2, 4, and their addition is equal to 1 plus 2 plus 4 is equal to 7, not equal to 8, and therefore this number is not perfect numbers, and this number is perfect. So now, by using C program, we are going to generate all perfect numbers which are less than or equal to n. So first we are going to write a code to check whether given number is perfect or not, and then we are going to extend this program to check whether to generate a perfect numbers less than or equal to n. So include stdio.h include conio.h void main. Now here we require integer. Say we are going to take a, then a sum is equal to 0. Okay, then printf enter your number. Okay, then scanf %d and a. Okay, now for I is equal to 1, now we are going to determine all divisors of a. I less than a, I plus plus. Now if I modulo if a modulo I equal to 0, then sum is equal to, if a modulo I equal to 0 means what? Number a is divisible by I, so sum is equal to sum plus I. Okay, now we are going to check close for loop. Now we are going to check whether sum is equal to I. If sum is equal to I, then printf it is a perfect numbers, else it is not a perfect number, printf not perfect. Okay, now get ch. If you compile here, one error, undefined symbol, so we want to define here I, define integer I. Now if we run here and if we enter here 6, you can see here it is perfect. If we run one more times, if you enter say 10, sorry, it is not a perfect. We want to clear the screen. Now if you run one more times and if you enter 6, you can see perfect. If you run one more times and say 12, it is not a perfect numbers. If you run one more times and print 28, it is perfect number. Okay, now we are going to generate a perfect number less than n. So take one more integer variable, say n, and instead of enter your number, enter n. I am writing here enter n, enter n, then scan a %d and n. Now we are going to take one more loop for j is equal to, sorry, for j is equal to 2, j less than or equal to say n, j plus plus. So we are going to take n numbers by using j, and we are going to determine all divisors of j. If j percent I equal to 0, again we want sum is 0 after every number we want sum should be 0. Instead of declaring here sum, I am declaring here sum is 0. So now if j percent I is equal to 0, then sum is equal to sum plus I. Now if sum is equal to j, then print the given number. Okay, printf the %d, say %d sum space, so, and the perfect number is what, j. We don't require else part since we are going to print all the perfect numbers in a range less than or equal to n. So now if we compile this, two errors, undefined symbol j. So we want to define here j. We are going to use this j to take a numbers from j, that is suppose n is equal to 10, then j is from 2 to 10, and we are going to check, or we are going to find all divisors of j by using this I loop for the second for loop. Okay, and if it is a proper divisor, then add the sum is equal to sum plus I, and then we are going to check whether sum is equal to j. So if you run, there is one more error, compound statement missing. So here j, we want to close the j loop. So after this, j loop is closed. So now if you run here and if you enter n, no, there is sum is equal to sum plus I, j is equal to 2, j less than, okay, sorry, here not a, it is what, I less than j, so we want all the divisors which are less than a given number. So given number is what, j. So we want to determine all divisors of j which are less, all divisors of j. Okay, so here now if you compile, if you run, enter your n, then 6 is a perfect number which is less than n. If we enter say 50, you can check here 6 and 28 are only two perfect number. If you run one more times, if you enter here 500, you can see here the perfect number is what, 6, 28, 496. If you increase the range up to say 1000, then there is no perfect numbers between 1 to 1000. So now you can increase up to 2000, 3000 and check whether there exists a perfect number which is greater than 1000. Okay, so between 1 to 500 there exist three perfect numbers, 6, 28 and 496. Thank you.